Now in Eg19 we have our parameter in terms of an angle rather than in terms of a value of t, which could well be time or something else. So in ellipsis parametric equations, x equals 4 cos theta, y equals 3 sine theta. So we want to differentiate. So dx d theta this time. When you differentiate cos, you get negative sine. dy d theta will be 3 cos theta. Now using the chain rule, dy dx will be dy d something times d something over dx. The d something is the extra variable, which in this case is theta. So the thetas would cancel and you'd have dy dx. So dy dx is dy d theta, which is 3 cos theta. And times d theta dx means we turn that upside down. So dy dx will be minus 3/4, and then we've got cos over sine, which is cot. So dy dx at the point with parameter theta is minus 3/4 cot theta. This time we want the equation of the normal at the point where theta equals pi over 4. So if we just have a think about this, and the ellipse again is something that you don't need to be that familiar with in the current A-level course, but it's basically an oval shaped. It's going to look like that, and then we're going to have a point on that, say there. That would be the point P, and that would have an x coordinate of 4 cos theta and a y coordinate of 3 sine theta, because the point would be xy, but we're writing it in terms of this parameter. That would have a tangent, which we could work out the equation for, and it would also have a normal. And it's the normal in this case that we want to find the equation for. So I want to find the equation of this. Okay, where we've got y minus y1 equals m x minus x1. Okay, now the m in this case will be 1 over that. Okay, so it would be minus 1 over the m, which is this equation here. So what that then gives me is basically turning that upside down. You're going to end up with plus 4 over 3, and then when you turn the cot upside down it becomes tan. Okay, let me meander over here and do that for you. dy dx, can you see it in that colour, can you? dy dx is minus 3. Why have I said minus 3 and written minus 4? Start that again. dy dx, so I know it's minus 3 cos theta over 4 sine theta, or minus 4, 3, doesn't matter. Okay, so if I turn that upside down, I get 4 over 3 sine theta cos theta. So we change the sign and we turn it upside down. When we turn that upside down, I get sine over cos, which is tan. Okay, so that's where that plus 4/3 tan theta comes from there, in case you got a bit lost with that. So now the equation of normal at P, so at this general point P, would be y minus y1, which is 3 sine theta, equals m, which is 4/3 tan theta, x minus x1, which is 4 cos theta. So that's the equation of the normal, and I want that at the specific point where theta equals pi over 4. Now, I'm working with calculus. I need to be in radians. The clue is that the angle is in terms of pi. So on my calculator, I need to make sure I'm in radians. I'm not. That says degrees. So I need to go setup, number 2 for angle unit, number 2 for radians, and now I've got an R on my screen, so I know that's good. So I'm going to store pi pi over 4 storing x. So that pi over 4 is tucked away in my store. So I've got y minus 3 sine pi by 4 equals 4/3 tan pi by 4 bracket x minus 4 cos pi by 4. So y minus a sine of pi by 4, I've just got to do sine of x, which is root 2 over 2. So that's going to be 3 root 2 over 2. Tan of pi by 4 is 1. So that's going to be 4/3 x minus cos pi by 4, which is also root 2 over 2. So to get rid of that fraction, I'm going to multiply by 6 to get rid of the 2 and to get rid of the 3. So when I times through out by 6, I get 6y minus, so let's do this longhand so you see what I'm doing. So that's going to cancel with that 3 times. That's going to cancel with that twice. So I get 6y minus 3 times 3 is 9 root 2 equals 8 x minus root 2 over 2. 6y minus 9 root 2 equals 8x minus, multiply that out, you're going to get 4 root 2. So I end up with 6y minus 8x equals 9 root 2 minus 4 root 2 is 5 root 2. So 6y equals 8x, 6y minus 8x equals 5 root 2. So that is the equation of the normal at the point where theta equals pi over 4. And then the last part, by eliminating the parameter, so if I go back to the start, I've got 4 cos theta and y equals 3 sine theta. Now, whereas in the last example I could rearrange one expression and then substitute it into the other to get rid of the parameter. I can't do that here because the parameters are bundled up inside the cos and sine function. So there's a spot here that you need to make, and the spot is this. If I write this, so I get cos theta equals, and if I write this, so I get sine theta equals, I know there's a relationship between cos squared theta and sine squared theta. So instead of having cos, I can have x over 4 squared plus, instead of sine, y over 3 squared equals 1, or x squared over 16 plus y squared over 9 equals 1. And that x squared over a square number plus y squared over a square number equals 1 is the Cartesian form of the equation of an ellipse, which, as I said at the start, we don't need to worry about anymore in A level, but nevertheless it might be something you come across doing your university studies. So there you go, that's how we work with parametric equations and how we differentiate them. So this style of question, you've been working right the way through A level, where you've been given equations, Cartesian up until now, had to find the gradient function and then use the gradient function to find an equation of a normal or a tangent to that curve. So the structure of the question is the same. The only thing that's different is now there's a different way that they give you the initial equations.